Okay, so surface area and volume of spheres. Again, just have you sketch in, just as a reminder, surface area 2D and volume 3D. That should be pretty self-explanatory. The sketch of the sphere is hard to do. I'm going to use a cheat. So you need a circle. Your circle probably won't be as nice as that. And then what you're going to want to do is, if you can do this, sketch in like an oval through the middle, sort of like that. That's probably the best that you can do. Now there is a dot right in the middle that's generated by my computer here that will give me the center of the sphere, which I can draw in a horizontal, and of course that is the radius, obviously. Now spheres, just like circles, are defined by a radius. Okay? So if I draw a dot and then make a radius, I'm just drawing on the whiteboard now. If I rotate this around 360 degrees, what do I get? A circle. So the radius, of course, is the defining feature of a circle. You always want to talk about the circle or the sphere in terms of the radius, not the diameter. Most of the time, like on standardized tests, multiple choice questions, they will often give you the diameter. So whenever you see diameter, just a quick adjustment, cut it in half. Okay, whenever you see that, just cut that in half, and you want radius. You always want that. You typically never want the diameter. Okay? So just a little tip on diameter. The surface area formula and the volume formula, those can be derived with some higher level mathematics. So for us in Math 10, we just use them, and they are 4 pi r squared. That's correct. And the other one is 4/3 pi r cubed. Now a lot of people have already asked me what that 4/3 means. 4/3 is just a number that you're going to multiply onto pi and onto r cubed. Okay, so if you're putting that in your calculator, you can do this. In the calculator, you can go bracket 4 divide 3 bracket, and then you can type in your pi button, and then you can type in your r, and then the little power button, 3. So that's what it's going to look like in the calculator. Okay? That's if you want to just follow the formula exactly. Some people are probably going to just do pi r cubed in the calculator, and then you can just hit times 4 divide 3. That works as well. Okay? Okay, so I will do the next question just on the calculator. You guys can just write it in. Let me just whip this calculator up. Okay. This, very straightforward. Let's do surface area first. 4 pi, and then in this case r is 4 because you made the adjustment, and then squared. Square happens so often. This is surface area, 4 pi r squared. And the square happens so often that you have your own special button for it, okay? So now for volume, 4/3 pi r power 3. Okay? Surface area would be like if you wanted to paint maybe an art project or something, you wanted, how much paint would you need? And then volume would be how much gas could you like pump in there? How much space the gas would need to fill. Okay, so 201 and 268. Let's go back. So just make sure you got the right units. 201 and what was it, 268. Remember, you need meter square for surface area and you need meter cube for volume. If you omit those units in the written response, I'll have to dock a half a mark. So don't do that. Okay, it's an easy way not to lose marks. Just be organized, get those units in there, and now we can start some problems. Those ones are just straight calculation, pretty limited thinking involved. You're just following a formula. Now these ones, the first two, you will see these questions, like I would give this question in grade 9 and grade 8, like these first two. Even my son is a bit of a math nerd because I'm pushing him hard. He's not great at sports, but he's good at math, and he could do these problems probably, and he's in grade 6. So they're not overly challenging. They're a bit of a warm-up. Question 4, though, just in terms of your understanding level of difficulty, question 4 would be on my exam in Math 10. Okay? 2 and 3, a warm-up to that. So make sure you're reading. As you read, you should be thinking, okay, area, all right, I know area, two-dimensional. Okay, square, ooh, I know area of a square. Let me draw that square. And it's telling me the number. So all this is 50. You guys okay with that? The area is 50. So they're saying that the area is 50. Is that clear when I write it like that? The square is 50. Or if you were to read it, x squared equals 50. What it's saying is the area of the square is 50. Okay, so surface area is this. Or I guess because it's two-dimensional, you just put area. Okay, so how would you solve this? You've seen it with Pythagorean. You just square root. 7.07. And just a word on units. If the square is meter square, then the root is meter because it's one-dimensional length. Okay. This you need to understand, especially just in the terminology. The square is 50. The square's root is 7.07. That root, when you say square root, what people actually mean is the length of the side. So when I say what's the square's root, you're talking about the length of the square. If you talk about the square, it's the area. So like if I said the square is 49, what's the root? What's the length of that square? 7. If the square is 16, what's the root? Okay, so there's that relationship between x squared to x. You guys comfortable with that? We have to spend a whole chapter on squares and square roots. And then in Math 20, you work algebraically with some much more advanced roots and radicals. So hopefully you know your squares. And if you really want to get ahead of the game, you should know your cubes. Okay, let's keep going. Number 3, the trim on a circular tablecloth. If you're ESL, you don't know this trim, that's okay. If that happened like in a test, you don't know what trim is, I would definitely tell you. Like, that's not fair. Trim, they're talking about the perimeter. Okay? Now, if you ask me during the test how to do this question, I'd be like, I can't help you like that. Or in a test, you say, I don't know how to do this. I'm like, sorry, I can't help you. It's a test. But if you said this word that really has nothing to do with the math problem, I don't understand, can you explain that to me? I'd be like, for sure, I can tell you what that means. All right. Go find your, it's a circle. All the two-dimensional stuff is on the front at the bottom. Okay, so you can see circle at the bottom there, and then the perimeter of a circle, what do they call that? Circumference, right? So, and because they want us to calculate the diameter, you can use the C equals pi d. Normally I would use 2 pi r, but because they want us to go straight to diameter, here it is, pi d. Where do I put the 3.5 centimeters that they've given us? It's the trim. So I replace which variable? Good. 3.5 equals pi d. This kind of structure, you need to be able to solve this in a heartbeat. Something times d, or pardon me, something times pi is 3.5. What's that something? What's the opposite of timesing? So you just do this. And don't use 3.14, use the pi button. So 3.5 divided by pi, it's going to be really close to 1, 1.11. And millimeter. Just a word on also the language. It says to the nearest millimeter, so that would be the nearest whole unit. That's what that means. Nearest whole. So that would be 1 millimeter. It's pretty much 1 millimeter. Or, why doesn't it want millimeter from centimeter? That's so silly. Let's just switch this to a C. I'm not sure why they've done that. Switch that to a C. And just leave everything in C, centimeter. You started in centimeter, you'll finish in centimeter. Okay, so some reading, some algebra, and now that's a warm-up for question 4, which is the real deal. Okay, the volume of a sphere, go to my data sheet, volume of sphere. I'm not going to be lazy, I can write that down. V equals 4/3 pi r cubed. I'm also going to, in the moment I write this, I'm going to care about my penmanship. I'm going to write this so that stuff in the top is in the top, stuff that's in the bottom is in the bottom. So that 4 pi r cubed, you can think of this line being extended. All that stuff's in the top. The 3's in the bottom. So when I substitute in this 2500 here, because that's what they've told me, the volume is 2500, and then they want me to find the radius, I have a much easier situation, because I understand, and I remember my teacher, he's like upstairs, downstairs, left and right. Okay, that 4/3, think of the opposite of 4/3. What's the reciprocal of 4/3? Just flip it. What is it? 3/4. So in a sense, you would think that 4, which is upstairs on the right, goes downstairs on the left. And the 3 goes upstairs on the left because it's downstairs on the right. So you'd have a 3 up here, you'd have a 4 down here. Those are now switched to the other side. Have we isolated the r yet? What's still in the way? Pi. Where does pi go? Downstairs on the left. Okay, and now the calculator. I think a lot of people could do that, especially if they studied, no problem. But the calculator, every year, okay? So watch this. Can you just read out the top? What is it? 3, right? Times 2500, thank you, sir. Divided by 4 pi? Okay. Does that look okay in my calculator? Okay. This is wrong. Your workbook is perfect. This calculator here is wrong. Okay. I will do that again, but the proper way. What's the difference? What's the difference between those two there? The brackets, right? What does the brackets tell the calculator? Yeah. We want to tell the calculator that we have to divide by 4 pi. What this one here, that's the first one I did, the 5890. It's doing 3 times 2500 divided by 4 times pi. Okay, so don't be that person that does all their math perfectly on their page and then communicates the wrong answer because they screwed up on their calculator. That's the worst kind of mistake you can make. You do everything right and then you don't get paid off. That's the worst. Okay? That's like long distance runners who are so healthy, they take care of their bodies, they don't eat fast food, and then they have heart attacks at age 40. It's so sad because you do all the right work, but then you don't get paid off for that. Like, that's a terrible feeling. So let's go back to this. What was that number? $596, beautiful. And that equals r cubed. Now we've been doing square roots for squares. How do we find the cube root? All right, so on this calculator, you can hit the math button. And then it's the fourth one down here that says cube root. And then I want that 596 to go in here. It was my previous result, so I'll go second function negative. And that puts the answer. My cursor is on that button. Second function negative, and that little A and S comes up. If you don't have this calculator, just take a few decimals with you. Like do 831 at least. Do 3 decimals and you should be okay. And then you see that's the radius, 8.4. Okay, so the radius is 8.4. And I used a cube root. If you can't find your cube root button, I will come around during homework and show you. What's the unit for the 8.4? Centimeter. Okay, it's a radius is a length, so it's one-dimensional, right? One-dimensional. So the unit is just centimeter. Radius is length. Beautiful. Let's keep motoring along here. All right, Rubik's Cube, trademark there. I always find it fascinating how some people can do these so quickly. I've never solved a Rubik's Cube in my life, and there's like 6-year-olds that do it blindfolded behind their back. I don't know how. It's like sorcery to me. So this 720 centimeter cube is the volume. So let's equate that to x cubed because the formula would be volume equals x cubed. You can find the cube at the top of your sheet, substituting in 720, and it's the exact same solution as the last question. If you can't find your cube root button, put your hand up. You have to hit math, and then it's the fourth one. Anybody else cube root button? Yeah, so you'll have to go second function this after your numbers typed in. Hit the math button. It's the fourth one. Math. Math. Hit it. That one right there. The fourth one down. Yep, hit enter. Now you can type the 720. Math. Yeah. Oh, that one, second function negative. We'll get your previous result. Yeah, and yours is so nice. You just go up into the history and copy paste. Math. Fourth one down. And if you wanted like a fourth root or a fifth root, use this one. And you just have to type the number first. Like if you want the fifth root, that's a fifth root. Yours will be right here. See the x root? You have to hit 3 first, then second hat, and then you can put in the 720. Math button. Yeah, the fourth one down, yeah. Right there. So see shift is yellow, yellow. So shift, then you can put the 720. Yeah. Math button on the left. Math button. Yeah, math button. And it's the fourth one down. Number 4. So you should be using like a, because you won't get that on your test, right? You're going to use something that you get comfortable with, so you're comfortable on your test. You can always borrow, right? You should get one. I highly recommend it. 120. But you use it all 3 years, and you use it every day, so your per day use is like a few cents. Okay, and that unit is centimeter. Okay. Again, so just to talk on what we're doing here. This cube, if you were to like fill the space with gas, that would be 720 square, or pardon me, cubic centimeters. When you do the root, when you do the cube root, the root is referring to the length. So this length is 8.96, this length is 8.96, and this length is 8.96. That's what they mean by that. Cube root. Okay, I want to get done in the next 5 minutes here, so let's get going. The moon approximates a sphere. It's very close to being a sphere, as well as the Earth. Very close to being a sphere. And they give you diameter. Automatically divide by 2. Just as soon as you see diameter, just divide that by 2. 1080. And approximate volume, you just pump this into the calculator. 4/3 pi r cubed, where you put the 1080 right there. So 1080 cubed, massive number. 1080 cubed times a pi times a 4, divide a 3, massive number. 527666986 mile. Okay. If you struggle with the big numbers, let me help you. Start from right to left. Boom. Oops, that was a mistake. Boom, boom, boom. Go in groups of 3 like that. You with me here? 1,000. Million. Billion. So this would be 5. In everyday language, this would be about 5.3 billion. And this unit would be cubic mile. Cubic miles. So massively huge. Now in a science class, you would go 5.3 times 10 to the 369 cubic miles. Okay? You should know these ones. 10 to the 3,000, 10 to the 6 million, 10 to the 9 billion, 10 to the 12 trillion. All right, hemisphere. Now, hemisphere is the weird one. It's quite interesting. It's on your bottom, very bottom. There's no picture. So let's talk about the hemisphere. So you have a tennis ball or something like that, or an apple, a really spherical apple, or an orange. An orange would be good. What happens when you chop that orange right in half? It is a half orange. Very nice. Let's draw that. Oh my gosh, how to draw this? It looks like a football. That's so bad. Yeah, half circle, okay. Beautiful. All right. So let's talk a little bit about the formulas for this surface area of a hemisphere. What is the surface area of a sphere? Let's start there. What's the surface area of a sphere? 4 pi r squared. And then what did we do to that thing? We chopped it in. I know it's 3, but we're going to start with the full. This would be the full circle, or the full sphere. What do we do to the full sphere to get a hemisphere? Chop in half, so divide by 2. And then what do you get? What's 4 divided by 2? 2 pi r squared. But the formula, like my friend over there said, was 3. So where does the extra pi r squared come from? When you chop it, you get this new face. When you chop it. And what is the shape of that face? A circle. So you have to add 1 extra pi r squared for a total of 3 pi r squared. Especially with your algebra, think about this as like 2 apples plus 1 apple is 3 apples. So the pi r squared is just an object. You have 2 of them here, you have 1 of them there, altogether you have 3. So that's the formula. You can just use it from your formula sheet, but I just wanted to show you where it came from. Alright, so 3 pi 5 squared, and you get the surface area. 235.6. You with me? Okay, surface area is a square unit. Now what is the volume? It's given as 2/3. Why is it 2/3? Compare it to the normal one, which is 4/3. Yeah, you cut it in half. 4/3 pi r cubed. If you were to put an extra divide by 2, because that's what we want to do, we want to cut it in half, then what do you get there? 4/6, which reduces to 2/3 pi r cubed. So that's where that formula comes from. Pump in the 5, just like we did up here. 2/3 pi 5 cubed. 5 cubed, 125, times the pi, times 2 divided by 3. 261.8 cubic centimeter. How you guys feel about that one? Is it okay? I'm going a little bit fast just because it's pretty straightforward at this point. And I want to talk about 8. Any questions about A and B? All right. I'll take your silence as you're all masters of this. What happens to the volume of a sphere when the radius is doubled? Okay, this is a challenger. 8 is tough. What happens to the volume of a sphere when the radius is doubled? Any guesses? Would the volume double? Would the volume quadruple? Would the volume be 8 times as big? Ooh. What is it then? You don't know? Let's just look at my whiteboard. Let's just say that's my circle. If I double the radius, what happens to the circle? Is it double the size? Is it double the size? How many of these little guys could you fit in this guy? How many do you think? 4. Because pi r square. What's 2 square? 4. This one, volume, what's the formula? Pi r for volume, pi r cube. So if you cube a double, What's the 2 cubed? Not 6. 2 cubed. Who said 8? Beautiful. 2 times 2 times 2. And if you said 6, you're not thinking. Right? 2 cubed is not 6. Okay? Don't don't make that mistake. 2 cubed is not 6. Okay, so let's talk about this. Volume of a sphere, jot that in. 4/3 pi r cubed. Okay. Now what are we going to do to this? What do we have to change r to? What are we going to change r to? We're going to change radius. How? Double it. So how do you double r? Who said that? Good. 2r. So change r to 2r. Everything else stays the same. And we'll call this v dash. Okay, now watch the algebra. 4/3 pi. Help me out. What's 2r cubed? What's 2r cubed? What does this power 3 even mean? What does exponent mean? Repeated what? Good, repeated multiplication. 2r, 2r. How many times do I have to do this? 3 times. 2 times 2 times 2, 8. R times r times r. All right, so 2r cubed becomes 8r cubed. Now these are all multiplications. Does it matter what order you multiply? No? So what I'll do is I'll put that 8 way out on the left, and I'll put the 4/3 pi r cubed next to it. I'll wrap the 4/3 pi r cubed in a bracket, and then I'll substitute in. Remember 4/3 pi r cubed we said was v? I'll put v right here for a substitution. The new volume is 8 times as big. Okay, perfect. That leaves us plenty of time for homework.